When it comes to the vast, black, unknowable expanse that is space, you wouldn't believe how little we really know. In fact, there are so few things that we do know, and so few of them make much sense, that it would be fair to say that we don't even know how much we don't know. And that's a strange position to be in, especially when we are faced with something as strange and mysterious as the black hole. Black holes are about the most bizarre of all space phenomena. Being invisible, always ravenously hungry, and capable of growing to sizes so humongous that they can continue growing infinitely. Now, let's compound that even more by looking at how NASA just discovered a new, unbelievably big black hole. What is a black hole? If we're going to try and wrap our minds exactly around what a black hole is, we first need to be able to understand gravity properly. If, for example, you decided to toss a ball in the air, then you are applying an amount of force with your hand necessary to elevate the ball into the air and temporarily repel Earth's gravitational force. The same thing applies when it comes to a plane taking off, or especially a rocket launch. For a rocket to be able to successfully launch, the speed of the rocket has to outweigh the gravitational attraction as well, which, when calculated, is called the escape velocity. Scientists have long since worked this out, of course, and we know that the minimum speed to be able to escape from Earth is 11.2 kilometers per second, which is just under 7 miles per second. That's already insanely fast. A black hole, by contrast, is able to consume even light, removing it, or perhaps replacing it, from its position in the universe. Therefore, we can safely assume that to be able to achieve escape velocity from a black hole's pull, you would have to be traveling at beyond the speed of light. Since we are not aware of anything currently that can travel faster than light, it's also arrestingly true that nothing can escape from a black hole once it has passed its event horizon, which is the invisible gravitational boundary around the black hole that stands as the barrier and point of no return. How do we know? So, we've established that black holes are invisible, and that is one of the most terrifying aspects of them. And yet, we also know what they look like. So, how can we see them? They appear to be just areas of empty black space, and the only way to actually see one is to notice the effect on the matter and light around it. Because of its incredibly strong gravitational pull, anything that is within the event horizon of the black hole is compressed tightly, so it cannot get out. The black hole creates a perimeter around itself of gas, dust, and other matter that is known as the accretion disk. Because these particles surrounding the black hole are moving incredibly fast, they also heat up from the kinetic energy and emit gamma rays as well as X-rays. These rays can be detected by our advanced telescopes and other equipment, and so we can deduce that when we encounter them, there is a black hole somewhere out there. The other way, of course, is to notice that when a black hole appears, the region surrounding it will begin to warp and twist, cluing us in that there is a strong gravitational pull in the area. While it's true that a black hole can be made from almost anything, you definitely need two things to create one, and those are high density and mass. If, for example, you wanted to make our sun into a black hole, and please don't, you would have to compress it down to a radius of 3 kilometers in order to create the required density. For reference, to create the same density out of Earth, you'd have to compress our planet to the size of a garden pea, or something else that's smaller than a centimeter. Of course, this would create an extremely small black hole, and some wonder if that's even possible. In theory, it is, because it is entirely possible for what are known as quantum black holes, or primordial black holes, to exist, barely bigger than a single atom. These tiny black holes have been speculated to be possibly the very things that make up what's known as dark matter. What kinds of black holes have we seen? Well, we know that stellar black holes exist. That much we have literally observed. They are usually created when a very large star explodes, for an instant shining brighter than an entire galaxy. You know already that I am talking about a supernova. Such a black hole would weigh about the same as 3 to 10 solar masses, that being 3 to 10 of our own suns. Cygnus X1 is a good example of a stellar black hole, and the first of its type that has been discovered. It is located in our galaxy about 7,000 light-years away from Earth. It is absolutely gigantic too, weighing in at approximately 21 solar masses, which sounds like more than enough to cause an apocalypse for the human race, but it's still kind of puny for a stellar black hole. The next kind is the intermediate mass black hole, and these are gargantuan, with it being possible for one to be thousands of times more massive than our sun. In 2006, telltale X-rays were discovered and tracked to a colossal black hole of this type in another galaxy, and this one was estimated to be about 50,000 solar masses in size. Of course, that is still nothing when compared to a supermassive black hole. In fact, one of those is currently sitting, as is common with most galaxies, smack in the center of the Milky Way, our home galaxy. Known as Sagittarius A star, it has an absolutely brain-melting 4,600,000 solar masses in its own mass, but actually remains roughly just 17 times bigger than our actual sun. Before you start panicking, note that while Sagittarius A star could snuff out our solar system in no time at all, it's 26,000 light-years away, so we're not really in any danger. Well, not for 26,000 years. What have we found? Recently, astronomers using the European Southern Observatory's Very Large Telescope, or VLT, yes, that is really its name, discovered a small black hole just outside the Milky Way by looking at how it influences the motion of the stars in close proximity to it. This is the first time this method has actually been used to reveal the presence of a black hole outside of our galaxy. And thanks to the success of the method, it could be used to detect other black holes within our home galaxy and other nearby galaxies, helping us to learn a lot more on how these phenomenal objects can be formed and grow. By using a process that they deem to be similar to Sherlock Holmes tracking down a criminal gang from their missteps, Sarah Saraceno from the Astrophysics Research Institute of Liverpool, John Moores University in the UK, led the research into the black hole, referring to the moving stars as wanted criminals and following their trails. Said Saraceno, "When you have found one, you are well on your way to discovering many others in different clusters." This black hole, dubbed NGC 1850, represents the first time a black hole has ever been detected in a young cluster of stars, which in this case is only about 100 million years old. Yes, that young. Using their method in similar star clusters could actually reveal even more young black holes, and this may be useful to help us to be able to understand a lot more about how they evolve. Because, as mentioned previously, we know frighteningly little about them. By comparing clusters with older and larger, more mature clusters, we can learn how they grow by either feeding on stars, merging with other black holes, or both. In order to perform their search, the team used data that has been collected over 2 years with the Multi-Unit Spectroscopic Explorer, or MUSE, mounted at ESO's VLT, which allowed them to observe the innermost regions of stellar clusters, examining the light from every single star in the vicinity. They found that they could spot odd stars that moved in strange ways, signaling the black hole, and the data allowed them to measure the mass of the black hole and confirm their findings. So, there you go. Not only have we discovered a new black hole, thankfully one very far away and no immediate threat to us, but we have learned a lot more about how to detect and identify them too. Black holes may remain as much of a mystery to us as anything else for now, but perhaps one day we will at least be able to understand them, though it's unlikely we'll ever outrun one.